Hi again. So in this video we're continuing to figure out and develop tools to factorize an algebraic expression. And here I have an example of an algebraic expression that you probably haven't seen before. So it's an expression of a form of x squared minus y squared. The key thing in this case is to notice that this expression contains two squared terms. So x squared is a square, that number 2 tells you it's a square, and y squared is also a square, and that number 2 in here tells you that it is a square. And the important thing to recognize is that there is a difference between those two squares. So what actually happens is that we know that if we see an expression of this form, x squared minus y squared, we can factorize this into an expression that looks like this. We have two brackets, and in the first bracket we have a sum of the two terms without the square. In the second bracket we have a difference, minus y. And that actually works out. If you want to check, we have x plus y times x minus y equals to x minus y plus y, x minus y equals to x squared minus xy plus xy minus y squared. Minus xy and plus xy cancel, and then we end up with x squared minus y squared, difference of the squares. Another way to think about it is to take a look at this square. And if I say that the side of the large square is of the length x, and the side of the small square is equal to y, the shape of the large figure, the white figure here, can be expressed in terms of the areas of the other two figures. So the area of the large square is x squared, small square area is equal to y squared. And if we want to compare, if we want to figure out what is the area of the shaded figure, of this figure here, that area will be simply equal to a is equal to x squared minus y squared. So that's kind of where this this formula comes from, and you can take a look at a little bit more depth in another video at how does this bring us into the difference of the squares formula. Why do we want to do it? Well, sometimes we want to use it to factorize expressions that contain squares. So if we look at this one, initially you can see that there is no way to factorize it by difference of the squares, because 20 is not a square and 125 is not a square. However, what we can do first is we can take a highest common factor out of the coefficient of those two terms. So if we take the highest common factor, which is HCF equals to 5, we'll take the 5 out of the bracket, and inside of the bracket we'll end up with 4x squared minus 25y squared. Now, what actually is happening over here, we have that 4 is a number that is a square, x squared is a square, minus 25 is a number that is a square, and y squared is a square, which means that we can apply our difference of the square formula, and we can transform what's inside in the bracket into a product of two brackets. So let's open the square bracket, and inside of the bracket let's take a look at what happens here. For each of those terms I need to find out what number was squared to get the elements of that term. So to get 4, I need to square number 2. to get x squared, I need to square x. And as we learned in the previous slide, I just write plus for the first bracket. And again, to get 25, I need to square 5. And to get y squared, I need to square y. So I just write that down. And I open up the second bracket. As mentioned previously, for my difference of the squares, I write the terms of this bracket exactly the same way, with an exception that inside of the bracket I have a minus instead of a plus, minus 5y. And I can close the square bracket. We can check that in a similar way as we did in the previous slide. So let's multiply 2x plus 5y by 2x minus 5y. So that will be equal to 2x minus 5y plus 5y, 2x minus 5y. If you multiply that all terms, I end up with 4x squared minus 10xy plus 10xy and minus 25y squared. These two terms cancel, and I end up with 4x squared minus 25y squared, which is my difference of the square formula from the inside of this bracket. And this is how I would use difference of the square formula to factorize algebraic expression. If you have any questions, you can leave them in the comments or find me on Twitter at Mr. Algebraic. Thanks very much for watching, and I will talk to you again next time.